This lesson is 3.1, where we are going to be measuring resistance. Okay, so like you had to answer in the previous lesson, what is resistance? Okay, so today we're going to be measuring what resistance is. And as you saw in the picture, each one of your resistors is a different color. So they have a different color band on them. We have one with a green band, one with a red band, one with a black band, and one with a gray band. So you need to, we're going to be labeling these A, B, C, and then our unknown. Okay, so we're going to have the red one as A, the green one as B, the black one is going to be C, and then the gray one is going to be our unknown. And we are going to be switching out our batteries. We're going to start with one battery in series, and then two, and then three with each resistor. And we are going to be measuring the current and the voltage with each one, and then we'll be calculating the resistance. And I will show you how to do that. All right, so if you remember looking at the picture, you had 4 different resistors and they had 4 different colored bands. We had one that had a gray stripe on it, one with a black stripe, and one with a green stripe, and one with a red stripe. Okay? We are going to test each one of them. Now, on your sheet, you have to identify resistor A, B, and C, and then you'll have an unknown. So for resistor A, I want you to use the red. For resistor B, use the green. For resistor C, use black. And then your unknown resistor is going to be the gray. Okay, so we're going to start with the red. And I'll show you how we have to set this up. You're going to have 2 clips on each side of your resistor. Okay, and if you can see this, here's our 4 clips, because this is one circuit by itself here, and then the voltmeter is in a circuit all by itself with just the resistor, because we want to only read voltage across the resistor and nothing else. And remember, a voltmeter will not work if it's in a series circuit, because once the current reaches it, it stops. Okay. So I've already done this lab, so I'm going to give you the information that was collected when this lab was performed. So with resistor A, which is the red one, with one battery in series, our current was 120 milliamps with a voltage of 1.5. For 2 batteries in series, the current was 240 milliamps with a voltage of 2.8. For 3 batteries in series, our current was 325 milliamps with a voltage of 3.9. Okay, then for resistor B, which is the green one battery, our current was 100 milliamps with a voltage of 1.5. For 2 batteries in series, our current was 200 with a voltage of 2.9. For 3 batteries in series, our current was 270 with a voltage of 4.0. For resistor C, which is the black one, one battery had a current of 150 milliamps with a voltage of 1.45 because it was between the 4 and the 5. Okay, two batteries in series had a current of 280 milliamps with a voltage 2.8. For three batteries in series, our current was 390 milliamps with a voltage of 3.8. Then for our unknown resistor, which is gray, for one battery in series, our current was 80 milliamps with a voltage of 1.5. With two batteries in series, our current was 170 milliamps with a voltage of 2.9. Then with three batteries in series, our current was 230 milliamps with a voltage of 4.1. Okay, and you do have to find the current in amps instead of milliamps. So for each one of your readings in milliamps, you will move your decimal place 3 places to the left, and that will be your number of current in amps. So for example, on resistor A, the current in milliamps was 120, but the current in amps is 0.12. Okay, and then for 240 is 0.24, and then for 325 is 0.33, because I rounded that 2 up to a 3 because there was a 5 behind it. Okay, and then for resistor B, the 100 milliamps is 0.10 amps, and then the next one is 0.20. Then the next one is 0.27. For resistor C, the current is 150 milliamps. Then you convert that into 0.15 amps. Okay, and then 0.28, and then 0.39. Okay, for our unknown resistor, the current in amps for the first reading was 0.08, and then the next one is 0.17, and then the next one is 0.23. Okay, and now we are going to calculate resistance for each. So to find the resistance for each one of our resistors, you take your voltage and you divide by your current. So for example, for resistor A, your voltage is 1.5, so you put that in your calculator and divide 1.5 by 0.12, and I get 12.5. Okay, and then I take 2.8 and divide by 0.24, and I get 11.7. Then I take 3.9 and divide by 0.33, and I get 11.8. And now the next one for B, 1.5 divided by 0.10, and I get 15. 2.9 divided by 0.2, I get 14.5. 4.0 divided by 0.27, I get 14.8. Okay, and then 1.45 divided by 0.15, I get 9.7. 2.8 divided by 0.28 is 10. And then 3.8 divided by 0.39 is 9.7. Okay, and then for our unknown resistor, take 1.5 divide by 0.08. I get 18.75. 2.9 divided by 0.17. I get 17.1 actually. Then 4.1 divided by 0.23, and I get 17.8. Okay, now that we have these, we are going to graph our current versus our voltage for each one of our resistors and identify the resistance for our unknown resistance. Okay, here is my graph that I made for current and voltage, and you can see my scale. The highest number that we had in voltage was 4.1, so I started my scale at 0 and I went all the way to 4.5. For current, our highest number was 0.39, so I did my scale from 0 all the way to 0.4. Okay, so now we are going to graph each. Okay, here are our 4 resistors that I graphed, and you can see there's 4 different lines. It goes unknown, and then B, and then A, and then C. And if you look at this graph, the more to the right the line is, the least resistant it is. Okay, so I'm going to write this on here. So I'm going to write least resistant. Okay, so that means that C resistor is our least resistant resistor that we checked, which means our unknown is going to be our most resistant because it's the farthest to the left. Okay, so let me write this on here. Okay, so the farther to the left it is, the more resistant it is, which means our unknown is going to be the most resistant resistor that we tested today. And if you look at your sheet where I calculated the resistance, okay, if you average, it looks like the resistance for A is about 12 ohms, and I'll show you how to write that. So A is 12 ohms, and you write that using the symbol omega. Okay, just like that. It kind of looks like a horseshoe, but upside down. Then for B resistor, it is 15 ohms. Okay, so B resistor is 15 ohms. C resistor is 10 ohms. Okay, and then the last one, our unknown, is 18 ohms. Okay, so there's our data right there. And you can clearly see from the graph that they go in order, 18, 15, 12, and 10, from left to the right. So that our most resistant one is the 18, that's our highest. And then our lowest is the 10, which is the one all the way to The picture that I posted for the resistor color codes, I want you to look up each one, and I will post a more close-up picture of each one of our resistors. But I want you to use the color codes that are in that chart, and I want you to just verify that each one of them is what I told you they are. Okay, I want you to prove it. And if you notice, the little gold stripe means that it has a plus or minus 5%. That means that your resistance can go up or down 5%. So like when we were calculating resistance, we got numbers that were very close to each other, but some of them were not exactly on the number that it should be. So that's what they're talking about. It can be 5% lower or 5% higher, just based on the circuit and how old the resistor is. Okay, so that is the end of our lesson, and let me know if you have any questions.